everyone, I am Kriti Sharma from International Institute of Professional Studies. I have been given a project on numerical analysis and design. The project is about bisection method on finding root techniques, on root finding techniques. So here is a graph where 2 points are given, A and B, and there lies a root in between of these 2 points. So the bisection method is the simplest among all the numerical schemes to solve the transcendental equation. The scheme is based on the intermediate value theorem for continuous function. Now let's consider an equation, say f of x is equals to 0, which has a 0 in the interval a and b. Say this is that 0 point. So here the condition is f of a and f of b. The product of these 2 points must be less than 0. That is, if this condition satisfied, it means the root lies between both of them. Otherwise the root doesn't lie. Bisection scheme computes the 0, say c, by repeatedly having interval a comma b, that is starting with c is equals to a plus b by 2. That is this point. We'll continuously keep on calculating the point a plus b by 2. While this process, the interval a comma b is replaced either by c comma b or a comma c, depending on the sign of fa into f. If fa into fc comes out to be positive, then fa is replaced by fc. If it comes out to be negative, then fb is replaced by fc. The process is continued until the 0 is obtained. Since the 0 is obtained numerically, the value of c may not exactly match with the all the decimal places of the analytical solution of f of x in the interval a comma b. Now, according to the explanation I gave just now, I have designed a code in R programming on RStudio. Here, first we will take a variable a, and we'll ask the user to enter a. Then we'll take a variable b. We'll ask the user to enter b. These will be converted into integers. If a cross a if function of a into function of b turns out to be positive, the interval will be invalid. Else, if it's negative, then we'll do the rest of the procedure. Since if they will be positive, there will be no root lying between them, so there will be no point of calculating the root. Now we'll take the midpoint of them as m, where m is equals to a plus b by 2. Here I will here is a while loop which keeps on calculating the midpoint of a and b with replacement of a and b by the value of m corresponding to the multi-product of them coming out to be positive or negative. So the while abstract of function m is greater than 0.0001, well if this line states that if the function of m is greater than is this value, then we still have to calculate the value of m, that is the value of root. Otherwise, if the value is less than this thing, then we have approximately found our root. We'll first print the value of I, which shows the number of iteration. Then we'll paste value of A, the first point, B, the second point given by the user, the M, which is sum of A and B by 2, and function of M. For our convenience, we replace f function of A with fa function of M with fm. Now if product of fa and fm is greater than 0, then a will be replaced by m, else b will be replaced by m. After this, m will be assigned the value of a plus b by 2 again, and m will be printed. And the I will get incremented each time the loop comes to its last step. As I told earlier, I is a number of iterations. After the whole procedure gets finished, that is, we find out what our root is, we'll paste the value of I, B, M, function M, and M, and the root M. Now have a look at the console. I enter A. I am entering the value A, say 1. Enter B. I am entering the value, say 2. Here prints all the values are coming in the every iteration. Here is our root. Thank you.